Hi, we are going to take notes on lesson 28E. We are continuing solving radical equations, but this time we're going to tie in what we know about rational expressions or giant fractions, and we are going to use our concepts of solving radical equations as well. So if we pull up the notes here, here's the vocabulary that we're going to use in the video, and when you see these words, make sure you highlight them so that I know that you're using vocabulary and that you can spell it and use it and see it in your notes. We are going to do two examples today. One of them, we are going to rewrite an expression, and then the other one, we're going to solve the equation. And so when I say rewrite, and it says to rewrite this expression in an equivalent form. So we're not going to get an answer like x is equal to. We're just going to rewrite it so that it is equivalent, but we are going to manipulate the denominator. So number one, example one, take this time to title your notes and to make sure you organize your notes so it says big ideas on one side, and then you can do your examples on one side, so it'll be easy for you to annotate every time you pause the video. So for example one, you're going to rewrite this expression in an equivalent form with a rational expression in the denominator. We learned that rational expressions are when there's a polynomial in the numerator and a polynomial in the denominator. So let's rewrite 1 over root 5, x minus 5 with a rational expression in the denominator. What we're going to do is multiply by the conjugate. So in this case, the conjugate is going to be the same terms, root x and 5, but instead of minus 5, the conjugate is going to be plus 5. And the reason why we do this is because we have this property that a minus b and a plus b times a plus b is going to equal to a squared minus b squared. And when we square radicals, they are released from the radical, so that's why this is helpful. But let's multiply this by the conjugate. So when you're annotating this, step 1, multiply by the conjugate. What we do the bottom, we have to do the top, so we have to multiply the same expression in the numerator as well. Now the denominator, there's a couple ways to do this. Some of you might be able to use this property of difference of squares. Difference of squares. We use this a lot. And just be able to say that x squared, root x squared, a squared, is going to equal to x minus 5 squared, which is 25. So some of you are able to skip right to the step, but some of you still prefer to use the box method, which is still an excellent technique. So we have root x minus 5, and we have root x plus 5. So root x times root x is x squared. Negative 5 times root x is negative 5 root x. Positive 5 times root x is positive 5 root x. Negative 5 times 5 is negative 25. And if we add these together, these cancel away, and we have x squared minus, just x minus 25, which would go into our denominator. So there's two ways to do this. If you're still using box method, that's fine. Make sure you note in your notes, use box method if you prefer to use box method. If you're going to use difference of squares, note, use difference of squares, and then use difference of squares. The numerator, we're going to just multiply using distributive property, and because it's a 1, and we get to use our identity property, and it's just going to be root x plus 5. I want to note that we are rewriting, we're not solving. So root x plus 5 over x minus 25 is an equivalent, I'll just write equivalent to 1 over root x minus 5. It's equivalent, and the whole reason why we did this was to rationalize the denominator. So we did this to rationalize the denominator. Okay, example number 2. At this point, before we move on, pause the video and take your notes. What else do you need to jot down? And then let's move on to example 2. Now we're going to move on to solving the radical equation, which means by the end of this example, we are going to have an answer. Either x is equal to something, there could be two answers, or there could be no real solutions, but we will have an answer to x is equal to something and what x cannot equal. So I'm going to take this example, 3 over the square root of x plus 3 is equal to 1 over 1. I'm dealing with a fraction here, so I'm going to convert this to a fraction because I am going to solve this by finding a common denominator. Now, when we did rational expressions, we had to find values that made the expression undefined. So let's talk about values that make expression undefined. An expression is undefined when the denominator is 0. So let's take a look at this denominator. And we have to ask, when is this equal to 0? So when is root x plus 3 equal to 0? Well, that's when the insides are equal to 0. So we can even use our solving technique by squaring this, which releases the insides of the radical. And we have x is equal to -3. This means that if we plug in -3 for x, the denominator will equal to 0, and then that will not be a solution. So right off the bat, x cannot equal -3. So if we somehow get an answer that says x is equal to -3, we already know that cannot be the answer. Now, how do we solve this? This was a side note on values that make the expression undefined. Now let's solve this. We need a common denominator, which is going to be square root of x plus 3 times 1, but I'm simplifying it to the square root of x plus 3. So this already has that common denominator, and then this side of the equation is missing the common denominator. So I have x plus 3 root x plus 3. When I do the bottom, I have to do the top. So now I have 3 over square root of x plus 3 is equal to square root of x plus 3 over the square root of x plus 3. The denominators are the same. When the denominators are the same, we can solve the numerators. When the denominators are the same, we can solve the numerators. Jot that down. Okay, denominators are the same, so we can solve the numerators. We're going to do the same thing where we square both sides, which means I'm going to take each side of the equation and square it. 9 is equal to x plus 3. So I end up getting x is equal to 6. In my question, we are solving, so I did get an answer, x is equal to 6. But of course, like every good scholar, I have to check my answer. Whoa, check my work. 3 over 6 plus 3 is equal to 1. And then I'm going to continue to simplify. Over square root of 9 is equal to 1. Is 3 over 3 equal to 1? And then indeed, 1 is equal to 1, always. Therefore, now I can go back and box my answer, and now I know that x is equal to 6. At this point, annotate the last of your example here, and then write in questions, write in things that surprise you, write in things that you need to remind your future self to remember, and then sum it up, summary. And we will see you in class tomorrow. Bye, everyone.